All right, Math 2, here we go. We've got lesson 5.2.4, Introduction to the Quadratic Formula. All right, so looking at this, we've got a problem here. It says solve the following first by the zero product property and then try completing the square. All right, so let's look at the zero product property here real fast. In order to use the zero product property, we have to factor this. So since there's not a leading coefficient, we can just ask ourselves what multiplies to give us -7 and then adds to give us -3. Let's see, there's only two things that multiply to give us 7. That would be 1 and 7. And there's no way I can get 3 out of that. If I've got 1 and -7, that would be -6. If I got -1 and +7, that'd be +6. There's no way to get 3. So therefore, I can't use the zero products property because I can't factor it. So it doesn't work. Now the zero products property is kind of a nice way to do things because factoring is pretty fast, especially if you're good at it. Problem with it is it doesn't always work. Now we do have another way of doing it, completing the square. Now completing the square always works, no matter what. It can get ugly, but it's always going to work. So if you like this method, then congratulations, you've got a method that always works. So I'm going to add 7 to both sides. So I'd get x squared minus 3x. I'm going to leave a blank here. And I'm adding 7 to both sides, blank over there. All right, the number that I'm going to add to both sides, here's where it gets ugly because I've got to take -3, cut it in half, and square it. So -3 over 2 squared is 9/4. Or we can write that down as 2.25. Let's just make it 9/4. All right, so I've got 9/4 on both sides. Now the perfect square that we made, we squared -3 over 2. So this is the perfect square of x minus 3 over 2. On the other side, if I'm going to take 7 plus 9/4, I need to change 7 into 28/4. So I've got 9/4 plus 28/4. That would be a total of 37/4. I think that's it. So over here I get 37/4. Now I'll take the square root of both sides. So I get x minus 3/2 equals plus or minus. Now the square root of 37 over 4 is the square root of 37 over the square root of 4. So I'm going to add 3/2 to both sides. And I get x equals 3 over 2 plus or minus square root of 37. Square root of 4 is 2, so I can change that to 2. Since these are both over 2, it's okay to write this as 3 plus or minus root 37 all over 2. So it gets a little bit ugly in there because I've got fractions. It would get even uglier if I had a leading coefficient because I would have had to divide by that first because this only works when we have a 1 in front of the x squared. So this isn't even as bad as it could get. So what we're going to see today is there's another method that we could use to solve these quadratic problems that's always going to work, just like completing the square always works. But instead we can just use a formula to solve it. So in standard form, a quadratic is going to have ax squared plus bx plus c, where a is the coefficient of x squared, b is the coefficient of x, and c is the constant term there. If we have something in standard form, remember it has to be in standard form with 0 on one side and all this stuff over there, we can use this formula, negative b plus or minus the square root b squared minus 4ac all over 2a. Now, how we got this formula, that's for another day. We'll actually go through on how that formula came about. But for this problem, we're just going to take that previous problem that we're going to look at, and we're going to solve it using this formula. So since this is now in standard form, the number in front of the x squared is a 1, even though we don't see anything there. When we don't see anything, we'll just say that that's a 1. So I now know that a is 1 because the number in front of the x squared, the coefficient of x squared, is 1. B, the coefficient of x, is negative 3. And the constant term c is negative 7. Okay, so now we're going to plug in these quantities to solve. So we're going to do it in a few steps. So first thing we're going to do is x equals, then it says negative b. So negative, and then I'm going to plug in b. I'm going to always plug everything in parentheses. It's going to keep me from making silly mistakes. So I've got negative b plus or minus the square root. And then it says b squared minus 4ac. Now b was negative 3, so negative 3 squared minus 4 times a is 1, times c, which is negative 7. All over 2a, so 2 times 1. All right, so at this point, I always clean up 4 sections. I start here, negative, negative 3. That's going to be positive 3. Plus or minus square root. Next section I clean up is right here where I'm squaring negative 3. Negative 3 times negative 3, this is 9. We're always going to get a positive number right here, because if you square a negative, it's still positive. Now here I'm going to multiply these 3 numbers. Negative 4 times 1, that's negative 4. And then negative 4 times negative 7, that's positive 28. So I'm going to multiply these 3 numbers next. That's my third cleanup area. So that's positive 28. All over 2 times 1, which is 2. Okay, I can still clean this up a bit. 9 plus 28 is 37. So I've got 3 plus or minus the square root of 37. All over 2. That's exactly the answer I got up here. Once you are familiar with this formula, you'll see that it's pretty fast to do, and it's way easier than completing the square, especially on these completing the square problems where you've got either an odd number here as your middle term, or if you've got a term, a coefficient in front of x squared, you're probably not going to want to complete the square with it. I mean, it's possible, but you're going to have fractions all over the place. I know how much you guys like fractions. All right, so the next one, these 4 problems, we're going to do these using the quadratic formula. Step 1, identify a, b, and c. So for this one, a is 3, b is 7, c is 2. Now I plug it into the formula. Formula is up here, negative b plus or minus b squared minus 4ac over 2a. I'm plugging that in. So x is equal to negative b, so that's negative 7, plus or minus square root of b squared, so 7 squared, minus 4 times a, which is 3, times c, which is 2. All over 2a, a is 3. All right, now I clean up the 4 spots. I clean up this one first. That's just going to be negative 7. Next spot, I clean up here. 7 squared is 49. Negative 4 times 3 is negative 12. Negative 12 times 2 is negative 24. Last spot, 2 times 3 is 6. I combine these 2 like terms right here. 49 minus 24 is 25. So this is negative 7 plus or minus 25 over 6. Now at this point, we would stop if the radical doesn't reduce, but the radical does reduce. So we always, at this point, ask ourselves, does this reduce? If it does, we keep going. So we all know that the square root of 25 is 5. So we got x equals -7 plus 5 over 6. Now this is two answers. Oh, plus or minus. Here's our two answers. -7 plus 5. That's -2 over 6. My second answer is -7 minus 5. That's -12 over 6. And both of those reduce to -1/3 and -2. Now, anytime that you get whole number answers, or not whole numbers, answers that aren't radicals, it tells us we probably could have factored this instead. And of course, the factoring probably would have been faster than this work. It's not hard work, it's just a little bit tedious. X1, A is 2, B is -9, C is -35. Okay, so let's plug it into our formula. X equals -9 plus or minus the square root, b squared, so -9 squared, minus 4 times A is 2, and C is -35. All over 2 times A, and A is 2. Okay, now we clean up our 4 spots. Clean up here first. That's +9. Next, -9 squared is +81. It's always going to be positive right there. -4 times, or 2 times -35, that's -70. And -70 times -4 is +280. That's brutal. All over 4. 2 times 2. All right, we're going to combine these two right here. So we've got x equals 9 plus or minus the square root. And 81 and 280 is 361 over 4. Yep, 4. Now some of you probably don't know this, but 361 is a perfect square. That's a perfect square of 19. So if you didn't know that, you might use your calculator and just double check to see if it reduces. So this is 9 plus or minus 19 over 4. So we're going to write down our two actual answers. One of our answers is 9 plus 19. That's 28 over 4. Our second answer is 9 minus 19. That's -10 over 4. Reduce these two. 28 over 4 is 7. -10 over 4 is -5/2. So since it came out as non-radical answers, this means we could have factored this one instead. Next one. A is 8. B is 10. C is 3. Okay, fill in the formula. X equals -b, so -10, plus or minus the square root. B squared, so that's 10 squared, minus 4 times A, which is 8, times C, which is 3. All over 2 times A, which is 8. Okay, now we start cleaning it up. We start here, -10. Plus or minus 10 squared, that's our next spot, 100. -4 times 8 is -32, and -32 times 3 is -96. All over 2 times 8, which is 16. Okay, those are 4 cleanup spots. Now we take 100 minus 96, we get -10 plus or minus the square root of 4 over 16. We ask ourselves, does the radical reduce? Yes, it does. That's a perfect square of 2. So we get x equals -10 plus or minus 2 over 16. We can write our two answers since there's no radicals left. Negative 10 plus 2, that's negative 8 over 16. Negative 10 minus 2, that's negative 12 over 16. Those both reduce. Negative 8 over 16 is negative 1/2. Negative 12 over 16, 4 goes into both of those, so we get negative 3/4. Last one. A, B, and C. A is 1. B is negative 5. C is 9. Oh, stabbed myself. What was I doing? Formula. X equals negative, B is negative 5, plus or minus the square root, negative 5 squared, minus 4 times A, which is 1, times C, which is 9. All over 2 times A, so 2 times 1. Okay, clean up. Negative negative 5 is 5. Plus or minus, negative 5 squared, 25. Negative 4 times 1 is negative 4, times 9 is negative 36. 2 times 1 is 2. Clean up in here, 25 minus 36 is negative 11. Now we're not allowed to have negative answers in our roots, at least not for now. So at this point, since I have a negative radical that doesn't exist, we're going to say no real. Stupid lights! Gosh! Almost made it. We're going to say no real solution. The end. Almost beat the lights that time. All right, that's all I got for you. Math hard. See you later. Bye-bye.